today we're going to be taking an adventure to a place I like to call Dense City. So if you've never been there before, it's a place where we learn about what density is and how it works. So you're going to be getting a packet, and so we're going to be able to follow along with the experiment. I'm also going to give each group a bag with some paper clips in it. So you can open up the bag right now, and I want you to take a paper clip. I want you to hold on to it. I want you to remember what color it is, because that will help you figure out what you're going to be doing in the science experiment. So before we start learning about density, we are going to go over the classroom expectations. So for the most part, you guys are really good about this, but I want to go over them specifically just so that we have a general understanding of how we act during science class, especially because we don't normally do a lot of science here in the 5th grade. Okay, so we're going to be respectful with our tools. So that means we're going to be working with a lot of different liquids and other things, so I want you to be careful with it. Those of you with long sleeves, you might want to roll them up because some of the things are going to be sticky. So just be careful with them. Don't fool around with them. Don't drink them. Just be respectful with them. And I trust that you guys know what that means. We're also going to be respectful to our lab buddies. So with our paper clips, we're going to have specific jobs. But I want you guys to still be respectful. Let our friends do the things that they need to do, and we work on the things that we need to do. And we're not going to be taking things or, just be respectful, be nice with each other. We know how to act like this. We're in 5th grade. We know how to be the good examples. When I call class, I want you all to promptly respond with yes. Now, this is something that we do normally in class, but I just want to clarify that. So we're going to practice it real quick. So when I say class, you say
yes.
Yes. Yes. And when you say yes, that isn't just using with your mouth. You're going to take everything that you're doing, you're going to stop, you're going to look, and you're going to give me your ears, okay? So that's 3 parts of your body that are working when I say class, right? So, class?
Yes. Yes.
So I want to see everybody's eyes, and I want you to show me that you're listening to me by giving me your eyes, okay? So even if I say class, class, you respond with
yes. Yes.
There we go. So whatever way that I say class, you have to respond with yes. So even if I go really high pitched and I'm like class, you have to say yes. Yep. You guys need to practice that because we can do better. I believe in us. Okay. Last one, we're going to be encouraging science. Now this is an acronym that we normally use when we do science projects, but we're going to go over it again. So we want to share, we want to be caring to each other, we're investigating, so that means you should have your looking goggles on, you're looking for things that might be different, that might be good things to learn about. We're earning knowledge, we're not just getting knowledge, we're doing things in order to get knowledge. So we need to be working hard so that we can earn that knowledge that we're learning. We are creating. So science isn't just about doing the experiment. We're in the process of creation together. We're doing something fun. We're learning. We're coming up with new ideas. It's not just like you do the things that you have to do and then you move on. This is a creative process. We want to be able to have fun with it. And then we're going to be extracting life lessons. So in science, you're not just learning stuff to learn stuff, you're learning it so that you know about it for future life. This is connected. Science is all around us. You go outside and you see the sun rising in the east and setting in the west. That's science. There are so many things to science, and if you just take the time to appreciate the science that we're doing, you'll learn a lot of things about life through them. Okay, so like I said before, we're going to density, and so we are going to be learning about why objects float. So, can anybody tell me what causes an item to sink or float? I'll give you a hint. It's one of the words that I've been saying a lot today.
It's density.
Density. So, an item's density causes it to sink or float. But what is density? Does anybody know? It's kind of a big
How
word.
much mass something has.
Yeah, so density is the relationship between the mass and the volume. Right? So when we're talking about density, you can normally measure density by you find out the item's mass, and you find out how much how much volume is in the item, and then you divide the mass by the volume. So if you look at whenever somebody measures density, normally the unit would be grams per milliliters or grams per centimeters cubed, I think, yeah. So this represents the mass, and this represents the volume. Okay, so that's how we find out what density is. So because we're going to be learning about density, we have to begin in the scientific process with stating the problem, right? So the problem that we're going to be investigating, and you guys should write this down on your paper so that you're keeping track of what we're saying. We want to state the problem, which is what causes an item to sink or float. So I want you guys to write that, and once you're done, put your pencils down and show me that you're ready. Okay, so your pencil should be down on your desk and your eyes should be on me if you're done so that I know that we can move on. Okay, so what is some information that we already know? So what did we just talk about? What is density? Because you could be writing this on your paper. What did we say density was?
Mass divided by volume.
Mass divided by volume. So you could put that in your information we already know section. And we also talked about the unit of density, and that's on the board, so you could put that on as well. So we know that density is what causes items to sink or float. So what density, like what kind of density would make an item float? Would a high density make something float, or would it be a low density? Does anybody know? Anybody want to take a guess?
No.
Well, you can tell me then.
Not so low.
What?
I said
Low? Okay. Sorry, I thought you said no. Okay. Okay, so a low density would make something float. So if you're putting two items, everything has so if you were to, so both items have density, right? So water has density, and say we're taking like a ball and we're putting it in the water. And if the ball is floating, so for example, if it was a soccer ball, generally soccer balls would float on water, right? You're a soccer player. Do you think a soccer ball would float in water? Yes. So that means that the water has a higher density than the ball, which has a lower density. So can somebody give me some examples of things that float? And we're going to talk about their density. So how about let's have you think, pair, share with your groups, and you come up with some examples, and then we'll write them on the board, okay?
Boats. Ships. Yachts.
People float.
Yeah. I said pumice.
What's that?
It's that one type of rock.
I thought you said hummus. I was like, cool.
Sometimes if you take like
Apples float.
bowls float,
Ice.
like if you like you go take a bath and you take like a
Doesn't
bowl of
it
chips.
float? Ice floats. Yes, it does. Ice floats.
Yeah, ice floats.
Does your ice sink to the bottom of your drink?
There's
I
something
think
in your
you should be
ice.
worried. What else floats? Spit floats.
Oh.
It does. Interesting. I did not think about it.
Does it float or does it just sit on top of the
I think
surface
it sits on
tension?
top. You're right. Boats. Okay. That's
So water spiders do not float; they just sit on top of the surface tension.
Interesting.
Does paper float? Or does it just? I think
Do you
it's.
guys have anything?
What do you think?
Well, yeah, that's the problem because it fills with water, so it becomes more dense.
So it's something can be.
Can you think of like wine? So, because do you think a pool noodle has a lot of texture? No, really light. So you're thinking about like the mass of the
Ooh,
pool
sponges
by the
float.
volume. People float. Do you think it would be like
I said that one.
Yeah.
So if you leave a immerse in the water a little bit, then maybe like put more water in the sink.
Yeah.
In their mouth.
Your osmosis.
Yes, exactly.
Okay, class.
Yes, yes.
Okay, let's try that again. Class.
Yes, yes.
Okay, so all eyes should be on me. So what examples have we thought about? Somebody?
Boats.
Yes, Cameron.
You said that the pool noodle that you have
That's a good
is really light, and so Miss Bussey was telling us that the mass divided by volume would be a lot lighter.
Yeah, so it has like a very low mass and a very high volume. So that would probably mean that it would end up being really a low density. Yeah?
Boats.
Boats? So why do we think that boats would float?
If they didn't float, then we would drive.
Yeah, that would not be very good. But let's think about it scientifically. How do we think that boats would be able to
Because
float?
they're more buoyant. They displace more water
Really big.
than they need.
Yeah, so boats generally have like a really large mass, right? But they also have a really large volume. And so when we think about dividing the mass divided by the volume, that would probably even out very well. Cameron, did you have something to say?
No, I'm sorry.
Did this table have anything?
We said that at home we have docks that are held up by like blue barrels.
So docks.
Yeah.
So generally wood
Yeah.
has a very low density, so it's able to float on water. So another example is that some people actually have a lower density than water. So like some people can just like float in the ocean. So like generally salt makes water more dense, and so because of that, it has a higher density than most humans. Because humans actually have a density of about like 1 grams per milliliter. So that's really interesting. Okay, so today we are going to be finding out if the paper clips that you're holding are more or less dense than these liquids. So what's going to happen? I'm going to have the purple, so you should have your paper clip. So can everybody show me where their paper clips are? So I know that you know. Okay, so the purple paper clip is going to be the supplies collector. So they're going to come up, they're going to get 4 cups, and they're going to, wait 1 second. So they're going to come up, they're going to get the cups, and they're going to bring them back to the table. Then the blue paper clip is going to come, and they're going to take the 4 cups that they just got, and they're going to fill them up to the line. So that one doesn't have a line. Right here, there is a little spot, and it's about half of a cup, but I didn't want to go through the whole process of trying to pour honey into measuring cups, and then that's like a whole mess of things. So we're just putting, I put the line there so that we all have the liquids at the same place, so that we can have a controlled experiment. Can anybody tell me what a controlled experiment is?
Only the independent variable is changed.
Yeah, so we only have one variable that's changing. Everything else is the same, so that we can observe and we can see what that one variable makes to change the experiment. So the blue paper clip is going to come up, and they're going to pour all 4 of these liquids up to the line. Then the yellow paper clip is going to be the cleanup person, so they're going to take all the cups at the end and put it away. And then the green paper clip is going to be the data dude, and they're going to write down all the information. Those of you that only have 3 paper clips, you could probably combine like, yeah,
What's blue?
one of the 2, whichever one you want. What?
What's blue?
Blue is going to be the pourer, so you're going to come up and pour all of the things into the cups. Okay, you will have more jobs as your paper clips come about, but so first we're going to have the purple. Can you come and get your 4 cups? soap instead. Okay, if So if the yellow paper clip wants to come up and get the cups, that'd be really helpful. Just because there's 4 of them and lots of things, so we want to make sure that they don't spill. So. Okay, so once you have gotten all of your stuff, I want you to leave them at the front, like right in the middle of your table. I don't want you to touch them anymore. You're going to leave them. And we're going to look through at what this experiment is going to look like. So you have your cup, and it has a certain liquid inside of it. And what you're going to do is, now that all of the liquids are poured, each paper clip is going to get a certain cup based on your color, and you're going to take the paper clip and you are going to put your hand right on the top of the cup like this, and you're just going to drop it. Because if we throw it in, that could change the experiment. So we all want to make sure that we're putting in the paper clip in the same way, so that we do the same thing where we don't, so we've controlled all of the other parts of the experiment. So can anybody tell me what the independent variable is in this experiment?
The kind of liquid.
The kind of liquids that we're going to be using. Everything else is staying the same, right? Because we're trying to keep everything together. Okay, so if we flip to the next page in our packets, you see each of the different liquids that we have, and then you have your cup with the liquids inside of it. And so what you're going to do is you're going to record on the cup where the paper clip lands, and then underneath where your liquid is, you're going to write any other observations. So because we're scientists, because we're investigating, I want you guys to keep an eye out for anything that might be different. So certain liquids, it might take a really long time to sink to the bottom, and other ones, it might take a really short time to sink to the bottom. So we want to be careful that we're making sure and keeping track of all of those things. So the blue paper clip is going to be dropping their paper clip into the water. So if you're the blue paper clip, you can take the water cup and put it right in front of you. The yellow paper clip is going to do the honey, so you can do the same thing there. The green is going to take the dish soap, and then the purple is going to take the vegetable oil. Okay, so you guys can go through and you can do your experiment. I want you to keep track, and I want you to share amongst your group how all of the different observations that are taking place, okay?
That's just sink. Water? That one like sink, but took longer to sink.
Yeah.
This one went straight to the bottom. Okay, yeah. And then this is
So did anything take a little extra
It was like
long? The dish soap is right where the corn syrup would be.
You just drop it in.
I'll go. Hers is gonna be most fun. Oh, straight. Straight. Guys, I'm so good at drawing paper clips. So good. Where's my paper clip go? Ready for this? Okay, does not sink. No, I think It's sinking. It's definitely sinking.
Hardly sinks.
Yeah.
Sort of sinks. Kind of sinks.
You kind of sink.
It kind of sinks in the same way that I kind of do my assignments.
Yeah, just sunk, just like the river water. It just sunk.
It's not sinking.
No, it definitely is.
No, like the stuff coming up to the holes, that does not count as sinking.
Straight to the
But
bottom,
it
I
sinks.
know what you're saying.
Where do you guys
The water goes straight to the bottom. Yeah. Dish soap slowly sink to the bottom.
Pop it in the microwave.
So once you are done with your
That's cheating.
experiment, I want you to put your hands on your head and you've observed everything and you've taken all of your notes. If you're still working, that's okay.
Kind of sinks, but not really. Water, honey, oil, dish. Water, sink, honey,
There's a
bloody,
table.
oil,
Okay.
sink, dish, sink.
Okay. Water. Oh.
Okay, show me that you're ready to move on with your hands on your head. Okay. So, does anybody want to tell me some of their observations about the water? So, group 1, what did you guys get?
It sank super duper duper fast.
Sank quickly. Yeah? Okay. Group 2, did you get the same thing? Okay. So, we'll just put this for it to show that it's just repeated. Group 3, same thing. Okay. What about the honey? Group 2, what did you guys get?
It floated on top.
You're floated on the top. Did you guys get the same? The same thing? Okay, let's just go as a class. What did we get for the oil?
Sank a little
It sank
slower.
a little bit slower. And then what about the dish soap? The dish soap?
Sank the slowest.
The slowest? Okay, so do we think that the density has impacted the way that these items sink or float?
Yes.
Yeah? Let's wake up a little bit. Yes?
Yes.
Yes? I think we need to like stand up and shake it off. Okay, so everybody just stand up real quick. We're just taking a quick shake off break. Because everybody seems really tired and we're not responding. Okay, so you're gonna shake off. We're gonna count down from 5 and you're gonna shake off 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then we'll count down until we get to 1, okay? Does that make sense? Give me a thumbs up if you understand what we're doing. Okay, so you're gonna go 1, 2, 3, 4, 5, and then you're gonna do 1, 2, 3, 4, 5. Same thing for 5, and then you're gonna go 4, 4, 4, 4, 3, 3, 3, 3, 2, 2, 2, 2, 1, 1, 1, 1, and then sit down. Okay? And we're all gonna count together so that it's not just me counting and we're getting our voices working, okay? Ready? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. It's just me. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 1, 2, 1, 2, 1, 2, 1, 1, 1, 1, 6. Do you guys feel a little bit more awake?
Yes.
I understand we're all tired, but we gotta get some talking. We gotta keep going. Okay, so do we think that density impacted the way that paperclip floated?
Yes.
Yes. Okay, so you think that the water maybe had what kind of density? The lowest density, and the honey had what? The highest density? Okay, so I want you to write down some of the observations. Like, we all got around about the same thing. So for your data, you can just kind kind of like do this thing because we all kind of had the same experiences. So I want you guys to write your data real quick. I'm going to give you a couple seconds to work on that, like a minute. So maybe communicate with your table, talk about it, write about other different data that you found, other things you observed.
Okay, so just because it's in. I said the home was the highest, and then I said it's kind of high, and the vegetable oil I said it was sort of low. Very scientific words.
Okay, so now that you have written all of your data, now we can make a conclusion about what we thought about the density. So I want you guys to write whichever one floated, whichever one you think has the higher density. I want you to write, like, I think that the paperclip is blank, or I thought that because it floated in this area, we can